So returning to the plants, which I know is most interesting for you people. When spring comes, uh, lots of warmth and lots of infrared energy, which means that easy water is going to build, right? And we found something that I believe is directly relevant for plants. A question has always been in the xylem of the plants. Xylems are conduits that bring water from the soil up and um, up the plant. And some plants, as we know, like redwood trees, are 100 meters tall, 300 feet tall, and this is a mighty column of water. If you took a pipe that's 100 feet tall and you filled it with water, the pressure that you'd feel at the bottom is enormous, right? So, but somehow the water works its way up to the top. Otherwise, the leaves wouldn't be green. And so what's going on there? Well, uh, and there I'll tell you about a discovery made by another student. Undergraduate students are amazing. Sometimes they're they're so creative. They'll do anything. Hey, I'll try this or I'll try that, and I encourage them always.
Happy accidents, I think, is how you term that, Gerald, if I remember correctly.
It was a happy accident. Yeah, it was an accident because this particular student. Uh, I assigned, well, I don't usually assign. I discuss a few possible projects, and the student chooses what the student likes to do. It works best that way. So, yeah, happy accident. So I asked him. We have just found that the polymer naphthalene, which we had been using quite a lot, we've been using sheets of naphthalene, and we just found out the naphthalene also comes in tubes, like a straw made of naphthalene. So I asked the student, I said, we know that a flat sheet of naphthalene grows EZs very nicely, but if it's curved, as in this tube, does the curvature impair the ability to grow EZs? So he did the experiment, and he quickly found out, no problem, lots of EZs in there. And I was away on a trip somewhere, I don't know, Europe, whatever, giving lectures, and he'd already solved the problem. He answered the question, and I wasn't there. And he thought, okay, well, I got to do something. So he started doing experiments on his own. And one day, when I had returned, I was sitting in my office with a visitor, and the visitor was maybe less than compelling. And I was sort of hoping the meeting would end. And fortunately, this same student barges in, and I pretend that I'm irritated because, he barged in and I'm speaking to somebody and he shouldn't interrupt that way. But he said, I got something I thought you'd want to hear. It looks pretty interesting. Okay, so tell me, what is it? I was actually delighted that he interrupted the conversation, but I didn't.
I love it.
I didn't want to demonstrate it. And okay, anyway, he said, I looked at the tube of naphthalene, just like a straw, horizontally situated in the chamber, covered by water. And he said the water kept flowing through the tube from one end to the other, and it wouldn't stop. And he said, I thought it was pretty interesting. I wanted to tell you that. And so I thought, if this is real, and we quickly confirmed that it was real, is really important because it would seem usually what you need is a pressure difference, a pressure gradient from one end of the tube to the other. But this tube was just lying in the chamber like this, the water equal height above both ends of the chamber, and it just kept going. And you need energy to do that. So where does the energy come from? We had just found that about the infrared energy. And I know infrared energy is coming to the chamber. It gets absorbed because water loves to absorb infrared wavelengths. And that energy was getting transduced by the water into something that produces flow. And we began to understand exactly what the mechanism is, but it had something definitely to do with easy water and the separation of charges. So I was, this was really exciting. And the reason I mentioned this is there are two reasons. First of all, it has something to do with the heart, which if you ask me, I'll tell you about. But it has to do with plants too, because one of the questions in plants is what causes flow? There are all kinds of flow in plants, including the one I mentioned before about the xylem and the flow from the roots all the way up to the top of the trees. And by the way, it's especially prominent in the spring and summer when you got lots of infrared energy. And I'm quite certain that the mechanism that I'm talking about, that this student identified in the laboratory, well, he identified the phenomenon, maybe not the explanation, that this is highly relevant and that this is indeed the explanation for all kinds of flows in plants, not just the xylem, but the phloem and anything else. It's hard to find the source or the reason for the flow, and I think we've identified it. Just to complete the story, if anybody is interested, what happens is an annular region of EZ forms just inside the vessel, outside too, but just inside the vessel, negatively charged. It discharges protons, as I was discussing earlier, as it forms. And so the protons are sitting around the axis, the long axis, central axis of the tube. And those protons are free. They want to get away from one another. And the more protons that are released to around the center line of the vessel, the more pressure you have to get out of there. They want to get away from one another, so they'll exit either one end or the other end. And once they exit, they're pulling the water with them because the protons are actually attached to water, giving you hydronium ions. And so those positive hydronium ions are going out one end and dragging more water in, and it just keeps perpetuating itself. And if you've got energy, if you've got infrared energy, the more you have, the faster it'll go. So that's with regard to plants, which I know is a subject of great interest here. But also, if I may, I want to talk about the heart.